Hello everyone. So today we will be solving problem of the day at Geeks for Geeks. Gold mine problem. Given a gold mine called mat, basically we have matrix. Each field in this mine contains a positive integer which is the amount of gold in turns. Initially, the miner can start from any row in the first column from a given cell. The miner can move to the cell diagonally up, right, or cell diagonally down. So, so we need to return the maximum amount of gold that he can collect until he can no longer do. Okay, so basically we have a matrix. If I if I'm at this cell, then I can move to this cell or this cell or this cell. So at each cell we will be having at most three possibilities of movement, right? And also states that we can start from any of the cell in the first column. Okay, so like if I start with this cell, then I have three possibilities. I can move to this one or this one, right? Okay, so let's just think about how I can solve this problem. uh, since I'm having some kind of maximum amount of gatherings after all the traversal in a path. So I might think of greedy approach, which can be helpful here, right? So let's analyze the greedy approach here. If I start with, if I'm this, if I'm at this cell, then I uh, have three possibilities. Okay, I can move to this cell or this cell or this cell. And the greedy approach, uh, what it will do, that it will um, force the miner to move to this cell because it is having the maximum amount of gold. But if I choose this cell, right, then I might land up to uh, this cell at the end, and the thousand value is much larger than all other values. Let's say I'm having 5 here and 6 here and 7 here, right? Although it's having the maximum, locally maximum value, but it is not helping us to find the base tensor. So greedy fails here, because the local the local maximum or minimum is not helping us to choose the base tensor. So okay, greedy fails here, and since I'm having just something to find maximum, and no other approach I can apply here. So I will think of dynamic programming. I can just make recursive calls and go in the right or in and explore all the three possibilities and reach to the last column and just track the maximum among all the possibilities. Some kind of approach, this approach can be applied in this problem. And After all those thinking in our mind, I just reached to a solution that okay, I can apply dynamic programming here because uh, in the recursive calls, I can make all the three possibilities and also all the n possibilities in the starting also, and efficiently can solve this problem by applying memoization or tabulation. We will see this later. So let's start with the memoization. So I will be requiring 2D table. Why? Why just 2D table? Let's analyze this also. So if I'm at this cell, I have two criteria, at least two criteria. That is, one is the row number, second is the column number, right? So these two is, field will always be the deciding factors or the transitioning states. But if some other condition also apply for the cell, that okay, if this cell has not been blocked or maybe other condition also given, so I will be making one more dimension on the DP, maybe 3D DP or maybe 4D DP, but here no other condition is applied, so just a straightforward approach will be there. And there will be just two transitioning state factors. That is, one will be the row number and the second will be the column number, right? Simple thinking. Right from the beginning, we will be first insert all the base cases. The base cases will be always, I can choose all the cells of the first column as our starting mine. And so for that, I will store the first column of the given matrix into the DP table directly. It will work, right? And then I can in the consecutive recursive calls, I will decide the best among all the possibilities. Let's apply the tabulation method also here. For the tabulation, I can use this 2D DP table or again, and I can simply traverse using two nested loops. And for the first column, I just simply inserting, which is exactly not required if because basically it's a base case and I have inserted this already, so I can also ignore this. But yeah, just for the board readability, I did this one. Okay. But for all other columns, I will be having three possibilities. Okay. So since I'm using tabulation method now, I will think just oppose in the opposite direction, right? In the memoization, I am going from left to right. That if I'm at this cell, then I can move in the right. But I will, in the tabulation method, I will think in the opposite direction from right to left, right? I will think that okay, if I'm at this cell, then I must come from this cell or maybe from this cell or maybe from this cell, right? These three possibilities will be there. And for that, for calculating the base answer for this cell, I must have these three values already. So I must traverse this DP table, uh, not row wise but column wise. Uh, just a common sense. If I need the base answer for this cell, then okay, these three cells are helping me to decide the answer for this cell. Then the base answer for this cell also should be already filled in the DP table. So for ensuring this to be perfectly work, I will traverse column wise. I will go to each column and fill all the cells of that column uh, by choosing the value from the previous columns. But one more catch here is for deciding the base answer for this cell or maybe any of the cell of this column, I just requiring the cells of this column only. This column is just a waste for this column number 3, right? So there is also a possibility of space optimization. That what I have applied here. I made a previous array, right? Previous array have the maximum or the base answer for the cells of the previous columns. Okay, so and each time after each um, row, after traversing each row of that column, I will just swap the basically not swap but copy all the current uh, current values of the current column to the previous that previous column array, right? So there is th th these are just a simple dynamic programming tabulation method code writing. You must have not must you must have seen these before also, not required to explain. But my main motive of making this video is to help you in thinking of any of the dynamic programming questions, right? How to think of how to think of any of the approach, like starting from any hint of for the any starting optimization approaches like binary search or basic arrays or uh, greedy approach, and then after analyzing all those approaches just ends up with the dynamic programming. So hope my motive reaches to you, and you also got the intuition behind this algorithm I written into the screen. Self-explanatory, and I also explain you all the possible way of writing the dynamic programming. That is, first one is the memoization, second is tabulation, and third one is the space optimization. Okay, so hope this video helps you. Thanks for watching.